Hey students, thanks for showing up for the reteach for your Unit 1 test over scientific skills. Make sure you listen closely and participate, and you shall find success on your read test. Alright, let's go. Let's get started. Alright, so first thing I'm going to ask you about is a metric system. So if I ask you about SI units, I'm asking you about the metric system. What kind of metric unit? So if we're going to measure length in the metric system, if we're going to measure length, then what is going to be the base unit we're going to measure in? You need to understand that basically we're only going to use 4 base units when we measure in the metric system. Our measurement's going to either have the word Celsius in it, grams in it, meters in it, or liters in it. So if we're going to measure length, which one of those will be the base word, the base unit for length? It begins with an M. All right, meter. All right, if we're going to measure volume in the metric system, volume will have the base unit of what? Kind of rhymes. It rhymes with meter, but it's not a meter. It is a liter with an L. All right, if we're going to find the mass of an object, what will be our base unit for measurement? It'll be the gram. And finally, for temperature, what is the base unit for temperature? In the metric system would be Celsius. All right, so really in the metric system, you just need to remember those 4. Meter, liter, gram, Celsius. If your measurement does not end with one of those words, if it doesn't have one of those words in it, it is not metric. So if I ask you, would a scientist measure anything? Would he ever use gallons? Gallons doesn't have the word meter, liter, gram, or Celsius in it, so no, he would not have a measurement of gallons. Neither would he have a measurement that ended with inches, or feet, or pounds, or ounces, or cups. None of those words have the word meter, liter, gram, or Celsius in it. Now, you can add a prefix to these words depending on how small your measurement is or how big it is. If we're going to measure something really, really small, then it can be way over here on the left side. It could be a milliliter or a milliliter. So it's a tiny measurement. If we are going to measure something really big, then we'll go all the way over here. Whoops. And it'll be a kilo. So kilometer, a kiloliter, a kilogram, that is going to be a big measurement, okay? So adding kilo or hecta or deci or milli or centa in front of any of these 4 words right here just changes how big your measurement is. It still is metric, see? Metric, meter, liter, gram, Celsius. All right, and these are our base units. Sometimes we just add prefixes to these words depending on the measurements. Something small, we're going to measure the length like a pencil, it'd be a centimeter. If it were finding the volume of a liquid in a graduated cylinder, we would do milliliter. If we're going to measure the mass of a car, then we would use kilogram because it's big. And then Celsius, typically we just use the unit metric Celsius, named after our temperature, degrees. Okay, so there you go with metric system. Now let's put all of this with some lab equipment. What do you think we would use to measure finding length in the metric system? What kind of lab equipment would you use? Okay, metric ruler. Or you could say meter stick. Metric ruler, finding length. Okay, volume. For finding volume, usually it's going to be a liquid. Not always. We found in our lab, we found the volume of a rock, but usually it's a liquid. So if we're going to use a liquid, what would be the most precise piece of lab equipment to get our accurate measurement? It's a big word. It's 2 words. Graduated cylinder. All right, graduated cylinder. Then we have mass. If we're going to find the mass of an object, that means how much matter it has. What piece of lab equipment would you use to find mass? Now, there's more than one answer, just as though there are more than one answers on finding volume as well. But mass, we're going to use 3 words. Triple, finish it for me. I know that you know it. Triple beam balance. We could also use an electronic scale, but in the classroom, typically we use a triple beam balance to find mass. Next, we have temperature. Celsius, we will use a thermometer. Or as I like some students call it, a thermometer. Why not? Thermometer. All right, so there's your little metric rules. SI units is as it's called as well. What piece of lab equipment would measure each one? There's your information. Now, what we need to do is practice measuring graduated cylinder, triple beam balances, and rulers and finding the measurement there. So let me turn on the projector. And we already have a problem on the board. Okay, so first thing you do when you look at a graduated cylinder is look at the scale. This one moves up. What do the numbers move up by? You see 2, 4, 6, so they move up by 2s. When you have a single digit scale, like this one, just, one number, see, the 6, the 4, you're going to have a decimal point for your answer. And then next thing, the key thing, after you've looked at the scale and you've seen how the numbers move up, you're going to look at where that water line is, or liquid line. And you need to measure at the bottom of the dip. Remember, we call that the meniscus. And what I tend to do to get an accurate measurement is I draw a line from the meniscus over to the dash. Usually I try to have a straight edge. Draw a line over to the dash that the meniscus is touching so that you can get a more accurate measurement. Now look at this. What's this middle big dash in between the 2 and the 4? All I'm asking basically is what number comes between 2 and 4, and hopefully you're saying a 3. So this is the 3. It's not quite in the 3 section. We're still in the 2, so it's going to be 2 point. And now you got to decide what dash is it on. So if it is a 2-point scale, like the numbers move up by 2s, or even if it moves by 20s, you're going to count the dashes by 2s. So this is 2 point. This is 2.2. This is 2.4. And you see this is on 2.6. Now, remember, in science, you cannot have what I call naked numbers. They must have a unit, the correct metric unit after the number. So if this is graduated cylinder, oh, dun, 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 go over here, graduated cylinder, finding volume. Now, liter's going to be a little big for graduated cylinder, so we're going to use we're going to use a smaller measurement, milliliters, so we can just write ml. So make sure on all your graduated cylinders, you're going to put ml, little m, big L. All right, let's do another problem. I gotta fast forward here. Okay. Sorry. All right, so look at our scale. Graduated cylinder, our numbers move up by what? You have 2, 3, 4, so they move up by 1s. Look at the meniscus, and I'm going to draw your straight line as much as I can over to the dash it corresponds to. Now, still not quite in the 3 section, we're still in the 2s. And now if you have a scale of going up by 1, then you could count each dash 1. So it's in the 2 section, so 2 point, and then 1, 2, 3, 4, 5, 6, 7, 8, 9. 2.9, and our unit, ml. 2.9. All right, so the next one I'm going to have you look at it first, and you decide, and then you can check my answer once I go over it. Or you can check your answer. Oh, this wireless mouse. Okay. Look at the scale. Goes up by 1s. I'm going to draw your line for the meniscus over here. All right. Let me get the glare. There. See if you can decide on your own first what this measurement would be. It is in the 3 section, so 3 point, and then now you need to see what dash it is on. All you do is count up the dashes by 1s. 1, 2, 3, 4. 3.4, and our unit, ml. I'm hoping that that's what you got. All right, let's do another one. I'm going to do a 2-point scale. You're going to do this first. Let me draw your line for you so you can see it better. All right. I want you to try to decide what it is first. Because it's a 2-point scale, you're going to need to count the dashes by 2s. Okay, so the meniscus is in the 4 section still, because here's our 5. It's not in the 5s yet. And now we're going to put a decimal point. And here is 4.2, 4.4 ml is our answer. 4.4 ml. Okay. Let's do another one. Okay, now we're going to do a double-digit scale. You see how these numbers are, 30, 20, 10. So look at your scale. 10, 20, 30, they go up by tens. You are going to not have a decimal point number. Whenever you have a double-digit scale, like see there's 2 digits, you will not have a decimal point. You're going to just have a whole number. It'll be a double-digit number. Okay, so let's draw the line from the meniscus over to the dash that it's on. Basically, we use a lot of the 10-digit scales in the class for the graduated cylinders. You're reading it like a ruler, pretty much. So can you please decide what the number is that it's on? Okay, if you look at the middle dash here, this is going to represent the 15, so all you do is count up, there's 16 and there's 17, so it is 17 ml. See, we do not have a decimal in our number because it's a double-digit scale. The single-digit scales will have a decimal point number in the ones we're using. Okay, let's do another one. Let's look at the scale. The numbers go up, see, 20, 40, 60. So they go up by 20s. All right, so let me draw your line. Since this goes up by 20s, you will have to count your dashes by 2s. So move up by whole numbers by 2s. Here's the 20. Count up by 2s. This is 22 ml. 22 ml. All right, I'm going to do one more. You need to do it, and then we'll move on to a different piece of lab equipment for measurement. I'm going to draw your line for you so it's easier to see. Okay. You decide. Okay, so I'm hoping that you counted these by ones. Here's 21, 22, 23, 24 ml. All right, let's go and measure. I think we have rulers next. Yes, we do. Okay. So what's nice about this ruler is it already tells us our unit, okay? But in your answer, you still need to write it, okay? It's centimeters. The line is not even in the 1 section yet, so we're going to start already off with the decimal point number, okay? So now you just need to count what dash is it on. Well, on a ruler, that bigger dash is always the halfway point, so this is 5, 6, 7, 8. So 0.8, and then don't forget your unit, cm, 8 centimeters. Rulers are never a big issue with my students. You guys really get those pretty well, so we'll just do one more and then we'll move on. Okay, you figure it out first. That glare is kind of right in our way. I'm hoping that you are understanding that this line is in the 1 section, so 1, and then what dash is it on? It is on the 4, and then cm, 1.4 cm. All right. And let's go to my favorite kind of measuring is a triple beam balance. There you are. Okay. When you have a triple beam balance, first of all, you need to remember, whoops, go back over here. We're finding mass. See, triple beam balance, finding mass, and we're going to use gram as our unit of measurement. And look, what's nice on this picture is it has it labeled for us too. See the little G's? All right. What I like to do is go ahead and put the place values, hundreds, tens, ones, point, tenths, and then go ahead and put my unit just to be safe, because I will count it wrong if you don't put your unit. All right, what is it pointing to in the hundreds? Well, it's actually on a 0. You can either leave it blank in this first one or put your 0. We're going to go to the tens section. It is pointing on the 90, so there we go, 9. And then now we look at the bottom beam. And it is in the 9 section. So we're going to put a 9 right here. Whoops, let me go back. Now, after the decimal point, we have to decide what dash is it on. So it is on the 5 dash, 99.5 grams. Okay, you do the next one on your own, and then we'll check your work. Don't forget that grams. Okay. Sorry, it's a lot of walking back and forth, but that's just how I have to do it. All right. Let me get where hopefully you can see. You decide. All right. Hopefully that's enough time. All right. So on the hundreds, it is pointing to 100. Then we go up to the tens. It's pointing on the 50. So we write a 5. Okay. Now the bottom beam, it's in the 5 section. And what dash? It's on the 2. 155.2. Okay. The last thing that we're going to go over is control and variable. Okay. If you guys remember in class, we had this example about Smithers. Oh, this was on our test. We had Smithers wanting his workers to staple faster. Okay, so he took 100 of his workers, and he has 2 groups. He gave group A the special juice to drink while they worked. He was hoping that they would staple faster. Group B did not get a special juice, but they still had a staple. Okay, so everyone's stapling, but Group A has been given something. They've been given the special juice to see if it'll make them staple faster. All right, so my questions to you are, what did Smithers add into the experiment to change it up? Hopefully you said special juice. Okay, now we have a name for that in science. What kind of variable is that if we add it into the experiment, or we're adding it in to change it up? It is called the manipulated variable, or you could say independent, but it's the manipulated variable. It's what's added in to change it up. And what's the control group? What is the same? What group is the control group? They did not get anything different. That would be group B, because they did not get anything different. They were just plain Jane, doing the same thing they've always done, stapling papers, nothing special. Okay? Now, let's go back to the manipulated variable. Manipulated variable was the special juice. That's what he added in. So if he's adding that in, what is he hoping will happen because he's adding in the special juice? He's hoping that they're going to staple faster. That is our responding variable, or you could say dependent variable. But that's the responding variable because that's the response of adding in the manipulated variable. So did it work? And as you can see in the last sentence tells us the results. It did not work. Now, the other thing is you could think of what could he have done differently? So to change this up, what could he have done differently? You might say he should try out more workers. Maybe try a different juice. Maybe he should, go through the people more and ask them questions more, question them out, get the same kind of people. It just depends. There's a lot of ways you can change it. Now, another example we had in class, let me just close this because I'll write a note here. Another example we had was about SpongeBob. And I'm just writing the words that I'm talking about, manipulated. And the responding variable. And SpongeBob wanted to know how he can get his pants cleaner instead of just washing them in water. Okay? So SpongeBob took his pants and he decided to use Cleano detergent. Do you remember this example? Okay. Cleano detergent, he added that into the experiment because he wanted to see if that helped get his pants cleaner. Now he did this experiment, and he already done it in water. He used the Cleano detergent, and it turned out that Cleano detergent didn't work any better than water, not one bit better. So let's go over this. What was the control group? What did he use the same in all of his experimenting? Okay, he used water. Just plain water was the control. Okay. That was what he did with his pants beforehand. Then he changed it up. He started adding something in. His manipulated variable, what did he add into the experiment? And I'm hoping you're thinking Cleano detergent, or you could just say detergent. That's his manipulated variable. Now, because he added in the Cleano detergent, what was he hoping would happen? Which would make a responding variable. He's hoping that his pants would be cleaner. So cleaner pants. All right, that is our responding variable. We also had the example where Mr. Krabs, he wanted his clients to have better breath after eating Krabby Patties. So he took 100 of his customers, and they all ate Krabby Patties. He gave every single one of those people a mint, but he gave one group a special secret ingredient mint. So my questions to you are, what was the manipulated variable? What did he add in? He added in a secret ingredient. That's our manipulated variable. What was he hoping would happen because he added in the secret ingredient? He was hoping they'd have better breath. So that is called our responding variable. And the control group, that was the group that didn't get anything different. It was the group that got a regular mint. Now, do you remember what happened? Did that secret ingredient breath mint work? Yes, it did work. It did work. They did have fresher breath. Okay,